Okay, let us see the next second use of dimensional analysis. The first use we have seen last time, and it was about checking the correctness of the given physical equation. So whether the given equation is correct or not dimensionally, that we can check. Now this is second use to determine or to derive the relationship between different physical quantities. So to explain this use, we are going to consider two or three examples. First example we will take from our notes, and in our notes the problem is given like this. If we consider a liquid column, say water column, so this liquid water has certain density d, it has height h, and g is a gravitational acceleration. So we know that this water column will have some mass. Let m is the mass of the water column. So what is m into g? It is the force, gravitational force acting on this water column due to the earth, and this gravitational force is always in the downward direction. And this force I will show here. This force, and this force is acting on this much area A. So yesterday we have seen that this force acting per unit area, it is called as the pressure. So this liquid column has certain pressure, and that pressure depends upon mass. Mass depends upon the density and volume. Volume depends upon the area cross section and height. So this pressure, it depends on height of the water column or liquid column, density of the liquid used, and gravitational acceleration. So what to find a relationship between these four quantities. This is our first problem. We don't know the relation between these four quantities, but we can derive it by using the dimensional analysis. So what is our first problem? We have to derive the relationship between pressure of the liquid column in terms of height of the liquid column, density of the liquid used, and g is a gravitational acceleration. So we have to derive this relation by using dimensional analysis. So the equation will be of this type: P is equal to some constant into h dg. But what is the power of h? Whether it is h or h square, or in kinetic energy we get 1 half mv square, so v square. So whether it is a h raised to 2, h raised to 3, h raised to minus 1 half, h raised to minus 2, etc. So we don't know the power. Question mark, question mark, question mark. So this type of relation we have to derive, and the procedure is using the dimensional analysis. So like this, so we can start deriving the relation like this. So our first problem is this. Example number 1. Let the pressure of the liquid column P depends upon three factors: H, height, D, density, and G, gravitational acceleration. So P depends upon H, D, and E, and therefore we can say that P is directly proportional to H, D, G. We don't know the power, so let the power of H is equal to X, X is equal to question mark. The power of D is equal to Y, Y is equal to question mark. And power of D is equal to Z, Z is equal to question mark. Now, in science, particularly in math and physics, we know that when we remove the proportion design, we have to take some constant, and therefore the pressure P is equal to some constant of proportionality K into H raised to X, density raised to Y, and gravitational acceleration raised to Z. So this is equation 1, where K is a dimensionless, it has no dimensions, dimensionless constant of proportionality. Dimensionless constant of proportionality. So this is our problem. Means we have to decide the values of x, y, z. So x is equal to question mark, y is equal to question mark, z is equal to question mark. This is our problem. So if we calculate the value of x, y, z, substitute here, and then k is a constant of proportionality, either it can be calculated by trial and error method or by experimental observation. So we will see the value of k afterwards. First, let us decide the value of x, y, z. So procedure is like this. Procedure is like this. Writing the equation 1 in using dimensional. Dimensionally means using dimensions. Dimensionally. Equation 1 is, so left hand side dimensions of pressure, P for pressure, is equal to dimensions of K multiplied by dimensions of height, H raised to X, dimensions of density raised to Y, and dimensions of gravitational acceleration raised to Z. So we know the dimensions of all these quantities. In the previous lecture, we have determined the dimensions. So dimensions of pressure is equal to the dimension माहिती नसतील आपण separately बघतो करून. So pressure is equal to force upon area. So dimensions of force are important. I will write down again the dimensions of force. We will require it so many times. So this is equal to m raised to 1 mass multiplied by acceleration L into t raised to minus 2. So dimensions of pressure I will calculate roughly is equal to dimensions of force m raised to 1 L raised to 1 t raised to minus 2 upon area. So area has dimension m raised to 0, L raised to 2, t raised to 0. So this L raised to 2 will become minus and therefore the dimensions of pressure are L raised to minus 1. We use LMD order, L raised to minus 1, m raised to 1 and t raised to minus 1. So these are the dimensions of pressure. So dimensions of pressure are minus 1, 1 and minus 2. So substitute here, left hand side. So better way I will write down LMT, LMT, LMT raised to x, LMT raised to y, LMT raised to z. So this K is a dimensionless constant, so power is 0, power is 0, power is 0. And pressure, just now we have found the dimension L raised to minus 1, m raised to 1, t raised to minus 2. Now height means it is the distance, dimensions of line. So it is L raised to 1, m raised to 0, t raised to 0. Now density, the density dimension माहिती नसेल तर आपण असे करू शकतो, mass upon volume. So dimensions of density is equal to dimensions of mass L raised to 0, m raised to 1, t raised to 0. So we can make the rough calculation side by side like this. Volume is L raised to 3, m raised to 0, t raised to 0. So this L raised to 3 will go up, it will become minus. So L raised to minus 3, m raised to 1, t raised to 0. So these are the dimensions of density. So here the dimensions are L raised to minus 3, M raised to 1, T raised to 0. And gravitational acceleration. Acceleration has unit meter per second square. We will write down meter into second raised to minus 2. So L raised to 1, T raised to minus 2, and there is no kilogram. So these are the dimensions of acceleration. So L raised to 1, M raised to 0, T raised to minus 2. Like this. So now simplify the left hand side. So these are 0, 0, 0, they are not counted. So in this first bracket, L raised to 1 multiplied by x. So L raised to x, M raised to 0, T raised to 0. Second term, L raised to minus 3 multiplied by y, L raised to minus 3y, M raised to 1 multiplied by y, and T raised to 0 multiplied by. Now L raised to 1 raised to z. So L raised to z, M raised to 0 multiplied by z, and T raised to minus 2 multiplied by z, 2z. Now use the mathematics. Add the powers. So L raised to, this is x, this is minus 3y, and this is plus z. Then M raised to, this is 0 plus y plus 0, and T raised to, this is 0, this is 0, and this is the minus 2 times z. And on left hand side, L raised to minus 1, M raised to 1, and T raised to minus 2. So this is the equation second. So these are the steps. The pressure quantity depends upon the height, density, and their acceleration. So we will write down this equation. We don't know the power of h, d, and g, x, y, z. So we have to find x, y, z. So write down the equation of each and every term. K is a dimensionless constant, so its dimensions are 0, 0, 0. Now collect the power of L, collect the power of M, collect the power of T, and now what is the next step? इकट्ठी L की power नहीं करते, L की power होते equate करेगी. Equating, this step is important. Equating powers of L, M, and T on both sides, LHS and RHS. So what type of equation we will get? See, this minus 1 is this, x minus 3y plus z is equal to minus 1. So this is equation 1. Now power of M, y is equal to 1. This is equation B. And minus 2 is equal to minus 2z. So minus 2z is equal to minus 2, minus minus cancel, 2z is equal to 2, and therefore z is equal to 1. So this is equation C. So put B and C in equation E. Put B and C in equation E. Put B and C. So we have to find the values of x, y, z. Right. So by solving this equation, we will get like this: x minus 3y, but y is equal to 1, so this is equal to 3 multiplied by 1 plus z, z is equal to 1, z is equal to 1, is equal to minus 1. So this is equal to x, this is minus 3 plus 1 is equal to minus 1. So this will become x raised to, x minus 2 is equal to minus 1, and therefore x is equal to, this 2 will become plus, so 2 minus 1, so x is equal to 1. So this is equation B. So now see, after getting the solution, we get x is equal to 1, So now I will add here x is equal to 1, then y is equal to 1, and z is also equal to 1. So this is the result. X is equal to 1, y is equal to 1, and z is equal to 1. X is equal to 1, y is equal to 1, and z is equal to 1. So only substitute the value of x by z in equation 1. Therefore, equation 1 gives pressure P is equal to K multiplied by h raised to x means 1, density D raised to y 1, G raised to 1. So this 1 should not be written, and therefore the pressure of the liquid column is equal to K into H into D into G. This is the formula. Now, so this is equation 3. This K is a constant of proportionality. This dimensional analysis has one drawback. We are going to see those drawbacks separately. We cannot determine the value of the K. We cannot determine the value of K by using the dimensional method. Either we have to determine it by trial and error method or by some experimental technique. So, in this case, it is found that by trial and error method, it is found that K is equal to 1. So, since K is equal to 1, therefore pressure of the liquid column is given by height of the liquid column, density of the liquid multiplied by gravitational acceleration. So this is the required relationship between the four physical quantity: pressure, height, density, and gravitational acceleration. Okay. तर ह्या पहिल्या प्रॉब्लेममध्ये आपल्याला मेथड माहिती व्हायला पाहिजे, नेमकी काय करायचं असतं. असे भरपूर प्रॉब्लेम तुम्ही स्वतः पण सॉल्व्ह करू शकता. हॅलो. So remember this procedure. The pressure quantity depends upon this factor, this quantity. So the relation is like this. So we don't know the power of HDG. Assume that symbol X व Z यूज केले पाहिजे, असं काही नाही. आपण PQR, MNP काही यूज करू शकतो as our convenience. And then write down the dimension. So this step is important. We must know the dimensions of all these quantities. Generally, the dimensions that we have seen in the last two periods, they are used in this type of equation. So this is the one problem. We have to find the relationship. What is our use to determine the relationship between the different physical quantity? Which are the different physical quantity in the first problem? Pressure of the liquid column, height of the liquid column, density of the liquid used, and gravitational acceleration. Now by using the same process, we can derive so many relations. So now I will take second example. Second example. So first we will take the example from our board book, and that problem is given example number 3.9. Example 3.9, page number 15. So I will read the problem. An object is falling freely under the gravitational force. Its velocity after traveling a distance h is v. If v depends on gravitational acceleration g and distance, prove with dimensional analysis that v is equal to k multiplied by under root gh, where k is a constant. इथे आपल्याला रिलेशन देऊन टाकलेलं आहे. Prove that v is equal to k multiplied by root gh. So we have to find the relationship between the three quantities. One is the velocity of the falling body. It is falling vertically downward due to the gravity. Then g is the gravitational acceleration, and h is the height from which it is released. So if it is released from this point, then as it moves, it has gravitational acceleration. So when we release it, its initial velocity is 0, but this velocity goes on increasing. So after covering distance h at this point, what will be its velocity? So we have to establish this relation between the three quantities. So procedure will be same. First step. What is the first step? Let V is directly proportional to G, gravitational acceleration, and H. So we don't know the power. So when we remove the proportionality sign, we add some constant, and therefore V is equal to some constant of proportionality K into G raised to say A and H raised to B. This is equation 1. A is equal to question mark. B is equal to question mark. So that power we can assume x, y, z, a, b, c, etc. like this. So we have to prove this relation. Now the first step we have completed. Now what is the second step? K is a dimensionless constant. K is dimensionless constant. Dimensionless constant of proportion. Therefore, dimensionally equation 1 is. So on left hand side we have to write down the dimensions of velocity is equal to dimensions of k 0 0 0, dimensions of gravitational acceleration raised to a, dimensions of height raised to b. This is the equation. And now we know the dimensions of all these quantities. Velocity, so many times we have used this meter per second, means it is L raised to 1, m raised to 0, and t raised to minus 1. K dimensionless constant L0, m0, t0, acceleration meter per second square. So L raised to 1, m raised to 0, t raised to minus 2, bracket raised to 8, and height L raised to 1, m raised to 0, t raised to 0, bracket raised to b. Thanks. So this is the same step. Writing the equation 1 using the dimensions like this. Dimensions of velocity meter per second, dimensions of acceleration meter per second square, and height means it is a distance. आता पुढचे स्टेप काय? Add the powers of L and T. So right hand side becomes L raised to 0, 1 and 1. 0 plus 1 plus 1. M raised to 0 plus 0 plus 0. And sorry. First we have to raise the power. So now this power 0 0 0 is not important. So in this case it will become L raised to 1 raised to a. So L raised to a, m raised to 0 multiplied by a, and t raised to minus 2 multiplied by a. So minus 2a. In this case L raised to 1 multiplied by b, m raised to 0 multiplied by b, t raised to 0 multiplied by b, and on this side L raised to 1, m raised to 0, t raised to minus 1. So now add the power of L. So L is equal to, here is a, here is b. So L raised to a plus b. M in both cases it is 0 0. So 0 plus 0 is equal to 0, and t raised to minus 2 times a, and this is 0. So this is the equation second. So on left hand side the power of L and T are like this: L raised to 1, m raised to 0, t raised to minus 1. Like this. So we have completed this second step. Now what is the next steps? In the next steps, we have to compare equating the powers of LMT on both sides. Equating the powers of length, mass, time on both sides of equation 2. So, if we equate the power, we will get two equations. In this case, there are only two variables A and B. Therefore, we will get only two equations. In the last problem, there are three variables X, Y, Z. So, it is the ordinary method. If there are three variables, we will require three equations. If there are two variables unknown, then we will require two equations. So, already we have got these two equations. So, if we compare the power of L, then what is the first equation? A plus B is equal to 1. So, this is equation small a. And now what is next equation? This is t raised to minus 1, this is minus 1. So, minus 2a is equal to minus 1. Like this. So, this minus minus will get cancelled. Therefore, 2a is equal to 1 and therefore a is equal to 1 half. A is equal to 1 half. This is equation B. Now, put B in A. Put B in A. So, substitute A is equal to 1 half plus B is equal to 1. So, this 1 half will become minus and therefore B is equal to 1 minus 1 half. So, that is equal to 1 half. So, A is also 1 half, B is also 1 half. This is equation C. So, A and B both are 1 half, 1 half. So, this power X, Y, Z or A, B, C or M, N, P, etc. They are not always positive, not negative. They may be integer, they may be fraction, they may be positive, they may be negative. Like this. So, now use this equation. Using P and C, equation 1 becomes. So, put in equation 1. So, velocity after covering the distance h is equal to k multiplied by g raised to a is 1 half, h raised to b, it is also 1 half. So, this power 1 half we can also write down like this. Root g means g raised to 1 half, root h means h raised to 1 half, and now we can combine these two roots. So, root g into root h means it is root g h. So, velocity after covering the distance h under the gravitational force become v is equal to k multiplied by under root gh. हेच आपल्याला करून करायला सांगितलं होतं. So, actually this k is not given in this equation, but to substitute the value of k as it is. But practically, this k comes to be 2. It is found. आपका problem नीचे समझेगा. So I will add here. It is found practically that k is equal to 2. Sorry, k is equal to root 2, and therefore this velocity v becomes root 2 multiplied by root gh. And now if we combine these roots, then v becomes root 2 gh. Actual relation is this, but in our board books we have to prove only up to this. This value of k can be determined either experimentally or by trial and error method. It cannot be determined by dimensional method. So we will derive this equation in motion in a 110 chapter. सोपं आहे रिलेशन डिराईव्ह करता येतं आपल्याला, नंतर बघणार होतं. सो बाय ट्रायल अँड एरर मेथड इट इज फाउंड दॅट के इज इक्वल टू रूट 2 इन दिस इक्वेशन. सो इफ यू नो value of k, write down. If you don't know, keep the k as it is. And therefore generally the equations are asked to derive using k. The value of A is not required. This is the additional point I have given. So please add in your notes. So this problem is from our board book. It is given in our board book. Example number 3, 9 number problem. This problem is given in our notes. So this is from notes, this is from problem. Now I will take one more problem, not from the book, not from the notes. It is outside problem. So you have to add in your notes book. After seeing this recorded meeting, you have to write down that problem. So that problem I will write like this. Means we are considering the third problem. So what is that problem? I will explain first in short. And then we will start the problem. Our problem is this. So we know this arrangement. It is called as a pendulum. You can say simple pendulum. This is a rigid support like a stand, and to this stand with the help of a string, thread, fiber, a bob spear is suspended. The spear may be of wooden, may be of gold, may be of cotton, thermocol, iron, any. So this is called as a pendulum. So length of the pendulum is measured from the center of the spear to the point of suspension. So this is the length L. Now on this pendulum, the gravitational force is acting in this direction, Fd. Fd is equal to mass of the pendulum multiplied by gravitational acceleration. So this is the initial position of the pendulum. Initial position of the pendulum. Fix a color plate. Now, if the pendulum is taken sideways, say here, so this is initial position O, this is position E. So pendulum is slightly deflected by some angle theta from O to A. And now this bob of the pendulum is in our hand. Now if we release this pendulum, then what will happen? Due to the gravitational force, it will go from A to O. Again, it will go from O to B automatically. Then again, it will return from B to O, O to A. Again, it will return. So it moves like this. It moves along the arc of a circle. This is the arc AB, AOB. So this is the center C. So this motion is in physics, it is called as a vibratory motion. It is called as a oscillatory motion. So we have seen this type of arrangement. Somewhere we have seen that there are wall clock, pendulum clock. So that pendulum oscillates. This is oscillatory motion. It has a particular period capital E. So that motion of the pendulum is used to control the motion of the minute hand, second hand, hour hand of the clock. It is called as a wall clock. So it is the theory of wall clock. So this pendulum, bob of the pendulum, when moves from A to O, O to B, this is half oscillation. Again, it will return from B to O, O to A, remaining half oscillation. So one oscillation to B. How we will calculate this one oscillation? Start from A, then A to O, O to B, again B to O, and again A. A to E, this is called as a one oscillation. So certain time is taken to complete one oscillation. That time is called as a capital D. It is called as a period. Time taken by the bob of the pendulum to complete one oscillation, one vibration, one oscillation, one vibration is called as a period. So this period of the pendulum depends upon length. Period of the pendulum depends upon length and gravitational acceleration. So this period depends upon length and gravitational acceleration. So we have to find the relationship between these three quantities. ऍक्च्युली हायस्कूल लेवलला तुम्हाला माहिती असेल, गॅलिलिओ जेव्हा चर्चमध्ये बसलेला होता तर तिथे ते झंबर लावलेलं होतं, तर ते असं ऑसिलेट होत होतं. तर ते एका ठराविक वेळानंतर ते रिटर्न व्हायचं एका पोर्शनमध्ये, म्हणजे तो पिरियड फिक्स होता. आणि नंतर मग गॅलिलिओने हे कॅल्क्युलेशन केले आणि याच्यातलं रिलेशन फाईंड केलं. सो दॅट इज द बेसिक ऑब्झर्वेशन. जसं न्यूटनला ॲपल खाली येताना दिसला, त्याच्यावर त्याने ग्रॅव्हिटीचा शोध लावला, तसंच आपल्याला. So period of the oscillating motion of the pendulum depends upon the length of the pendulum and gravitational acceleration. So what is the relationship between these three quantities? So the problem is same as this. Velocity depends upon the gravitational acceleration and height. Period depends upon the length and gravitational acceleration. The pressure of the liquid column depends upon the height, density and gravitational acceleration, like this. So method is same. So we will start this problem. So what is the problem? Now I will write down the problem. Example number 3. Show that period of oscillation capital T of a pendulum is T is equal to K multiplied by under root L by G. आता हा फॉर्म्युला आपल्याला प्रूव्ह करून दाखवायचा आहे. याच्यासारखाच प्रॉब्लेम झाला. Prove that V is equal to K multiplied by root G. Prove that T is equal to K multiplied by under root L by G. So same procedure. So for all these type of problems, the procedure is remaining the same. So again, start from the first step. Same steps. Let period means time period. Period capital T is directly proportional to the length of the pendulum and gravitational acceleration. So we don't know the power of L and G. So we will assume that, say, the power of L is equal to X, power of G is equal to, say, Y. So X is equal to question mark, Y is equal to question mark. Now remove the proportionality sign. So T is equal to K multiplied by L raised to X, G raised to Y. This is equation 1. K is a dimensionless quantity. It has no dimension. Dimensionless quantity. But if the problem is K dimension L0, M0, T0 together. So dimensionally equation 1 becomes, what is meant by T? It is a time. So dimensions of time is equal to dimensions of dimensionless constant, dimensions of length, fundamental quantity, raised to X, dimensions of gravitational acceleration, raised to Y. So time is a fundamental quantity. So L raised to 0, M raised to 0 and T raised to 1. K is a dimensionless constant, so its dimensions are L raised to 0, M raised to 0, T raised to 0. Now, dimensions of length. Dimensions of length. Length is again a fundamental quantity, and therefore its dimensions are L raised to 1, M raised to 0, T raised to 0, and bracket raised to x. Acceleration. So we have used the dimensional acceleration in all these three problems. Meter per second square. So L raised to 1, M raised to 0, T raised to minus 2, bracket raised to y. So this is equation 1, this is equation 2. Or better way we will call this equation 2 of curve. Now simplify. So this is equal to. Now L0, M0, T0, it is not necessary to take them. Now this will become L raised to 1 multiplied by x, M raised to 0, T raised to 0. Now in this case, L raised to 1 raised to y, so L raised to y, M raised to 0 multiplied by y, and T raised to minus 2 multiplied by y. So L0, M0, T raised to 1. So this is equation 2. So we have arrived this equation like this. So there are two unknown variables x and y, so we will require two equations, and the two equations can be easily obtained by using this step. Equating the power of LMT on both sides of equation 2. We are following the same steps. Equating the powers of L, M, T on both sides. On both sides of equation 2. So in this case, the power of L is equal to 0. So x is equal to 0. Equating this. Now m raised to 0. Sorry. First we have to add them x step of the raising. So collect the power of L. L raised to x plus y, m raised to 0 plus 0, and t raised to 0 minus 2y. L raised to 0, m raised to 0, t raised to 1. Now this is equation 2. Like this. Equation 2. And now equating the power of LMT. Equating the power of LMT on both sides. On both sides of equation 2. So 0 is equal to x plus y. This is equation small a. And minus 2y is equal to 1. This minus 2y is equal to 1. So this will give 2y is equal to minus 1, and therefore y is equal to minus 1 half. This is equation 2. X and y पैकी आपल्याला y ची व्हॅल्यू तर मिळाली. Now put this value here. Put b in a, and therefore x minus 1 half is equal to 0, and therefore x is equal to plus 1 half. So this is equation C. So we know x and y. Solve the problem. So using B and C, equation 1 becomes putting 1 in 1, and therefore period capital D is equal to K multiplied by L raised to x, but x is equal to 1 half, and G raised to y minus 1 half. So this can also be written as K multiplied by L raised to 1 half, and this is minus 1 half. It will go in the denominator, it will become plus. So this is equal to K multiplied by L raised to 1 half means it is root L. G raised to 1 half means it is root G. So root L upon root G, we can combine the root. So K multiplied by under root L by G. This is the required relation. This is equation 3. इथे आपला प्रॉब्लेम समजा. So in this case, K is a constant of propensity. Either we can determine the value of K by by trial and error method or by experimental technique. Dimensional analysis cannot be used to determine the value of K. Now in the next year, well standard, we can find this value of K theoretically as well as practically. So I will write down this value because I know this value. Practically, K is equal to 1 upon 2 pi, and therefore the period of oscillation of the simple pendulum is equal to 1 upon 2 pi multiplied by under root L by T. So if you know the value of K, then write down. Otherwise, you can keep the relation like this. So we have to prove that period of oscillation of the pendulum is equal to K multiplied by under root L by V. So period depends upon the length of the pendulum and gravitational acceleration. Longer the length, more will be the period. The period वाढला म्हणजे काय पेंडुलमला एका ऑसिलेशनला वेळ जादा लागेल म्हणजे मोशन स्लो होईल. Length increases, period increases, therefore motion will become slow. And if the period is this length is small like this, then it will oscillate fast. Like so, length factor is important. So to control the motion of the second hand, minute hand, and hour hand of a clock, we are using this type of pendulum. And that oscillating motion of the pendulum is converted into the circular motion of the minute hand, second hand, and hour hand. So that is called as a wall clock regulated by the pendulum. So this theory is used in the wall clock like this. So these are the three cases that we have seen. The procedure is exactly the same. The first problem it is given in our notes. Second problem is from board books, and this is the third extra problem. So I have given the problem. So first note down this problem. Show that the period of oscillation of a pendulum is T is equal to K multiplied by N L by T, and then write down this solution. So keep this problem with you like this. So we have taken three problems. Like this you can get so many problems, but there are again some limitations. So that limitation we will see at the time of drawbacks of this dimensional analysis. काय problems असतात equation derive करताना ते आपण नंतर बघणार. So okay, we will stop here today. Now there is one more use remaining, and that we will see in the next lecture.